Hello, it's Ryan here from RLF Vacuum Cleaners in Lakenheath, and in today's video I'm going to be opening up this ec-H2O module, which is a big bugger. On these ec-H2O modules from a Tennant T300 scrubber dryer, and these modules are fitted in quite a lot of different Tennant scrubber dryers. This one's from 2016, and they're pretty expensive beasts when they go wrong. This one was taken from a machine. We done an ec-H2O delete on. This is actually packed up. That's why I'm going to cut it open on camera. That's a heavy old beast. I'm going to open this up on camera and we're going to see what's inside. For anybody who doesn't know, I'll give you a quick brief history. ec-H2O is aqueous ozone. What happens is you pass a small electric current through the water, you end up with oxygen with, I believe, 3 oxygen atoms, which is a very good cleaner because it's very unstable. It's instability because it wants to go back to being H2O. So that third atom's always trying to go back to being water by splitting apart, and it's that force that's very good for cleaning. So what this means is Tennant can sell a scrubber dryer machine where you don't actually need any chemical to have a reasonably good cleaning power. Now, unfortunately, there are quite a lot of caveats. This isn't hospital safe, and it doesn't work particularly good on like really like grease and oil and blood and stuff like that. But it's all right for sort of like your general everyday cleaning. It's reasonably all right. I reckon it can save you a lot of money in chemicals. To be fair, I've never really had much success for ec-H2O. A lot of the machines I work on are usually sort of 3 or 4 years old, and these modules are usually knackered. These modules are about £600 each, with the filter bit here being £200. This last one was changed in 2018. So that's probably one of the contributing factors why it's failed. The filter's probably blocked up. But we'll give a quick tour how it works. You've got this big bracket on the back. This actually bolts it to the chassis of the machine. And what happens on the machine, at the bottom of the machine you'll have a big pump. And what that does is that pumps a little bit of water out of your solution tank onto the bottom like so. You've got these quick fit connectors. Now, I actually needed a couple of quick fit connectors because when you bypass the machine, you've got to take certain quick fit connectors out of certain places and snap them all back together. What basically happens is water comes in here, out here, through here into the machine, and then comes out on this pipe here to your scrub head. On the bottom, got a couple of connectors. Don't know how it's coming up on camera, but yeah, you got a big connector on the bottom. That's where your power and stuff goes in. And then you got this connector here, and then you got like another set of connectors here. And then on the back, you've got this big grounding cable to ground it out. This is mainly for sort of like static. What happens is the machines have a little conductor rubber bit connected to the ground. Basically, it's like a big rubber bit tied around the axle, and the rubber bit drags on the ground, and it discharges all the static electricity off the machine. Very clever. So where should we start? We will start with we'll remove the filter. Hopefully, I drained all this out, so hopefully there shouldn't be any water come out. The good thing about Tennant is they use these John Guest push fit connectors on everything, because that makes assembly and disassembly very easy. That's the water filter out. I do believe the top comes off these filters. I've never actually changed one. Yeah, these filters are about 200 quid each. So that's the filter off. What we got here, this must be some sort of pressure off flow sensor, I don't know. This cable tied on, so we'll cut that off. As here, we'll cut this cable tie off. So we've got here, got some sort of skew or shmoo over it. It's held on by these clips. Ah. So in here, it looks like we've got a little pump or something. Is that an air pump? Oh no, it's some sort of straight through pump. Interesting. So you got, that must be to pump that. So in there you got a little pump. You got a couple of wires coming off the pump. So that's what's in the box. Now, there's nothing else on the outside, so I think we'll have to unscrew the bracket. Get the bracket off. I'll bring in the screwdriver. That's the bracket off. What do I reckon the best way is? Well, we'll take these 4 screws at the back. That's then 4 screws out. We'll lift the lid off like so. Ooh, got quite a lot of capacitor in there. And a ribbon cable. That ribbon cable is going up to this little display here. It's got a little button on it. I'm assuming that must give you some sort of percentage, I don't know, some sort of filter indicator or something. So what we'll have to do is undo the plug at the bottom. Oop. That ribbon cable's alright. So on the back here, what we've got here, we've got a load of 680 UF 63 volt capacitors. 4 of them, got a big chip. What looks like to be some sort of like coin cell battery or something. Coin cell battery there. Got a big chip, pin header. Got a MOSFETs, resistors. A big connector here which comes on the machine chassis, but yeah, there's a little connector here which goes off to do the actual water zone. Glue, yeah, the capacitors are glued down. All I know is that this particular one just stopped working, so I'm looking for any sort of damaged component or anything that might give an indication why it don't work. All looks pretty good. But again, I don't think this will ever be going back on a machine. So what else have we got? There's no screws on the back, so it must just be these screws on the front. So lifting the top off like so, the back cover comes off, and this is the actual module itself. So it looks like water comes in here, goes up and around in the bottom, and it comes out the top. We've got lots of wires. We've got 3 wires go that way. 2 wires, so you've got 3 orange wires, 2 yellow wires, and then you've got 2 wires at the top go to the switch. How easy is this going to come out? I guess it's screwed in, isn't it? I will grab an Allen key and we'll pull this module out. So I've got my Allen key, we'll just open this up. Was that bolted in? No, it's obviously Allen keyed together, it's obviously. What does actually hold this together then? It's obviously held in. Ah! We've got these bolt heads, so it's obviously bolted in. I'll grab, is that 8mm? I reckon that's 8mm. I'll grab an 8mm socket. It's actually a 7mm socket. And does this. actually loosen them off before I turn the camera on, except for the first one. I should be able to lift this out. Remove these wires. So here we have the actual ec-H2O module, like so. Now it looks to be some sort of like honeycomb crystal. We'll open it all up. So you've got these two yellow wires, they lock in tabs. No, they're not. So you should be able to pull these off, hopefully. Pull these wires off. Hey presto, got the wire loom. Nothing here. Got a little sealed warranty sticker on. Yeah. Like I'm ever going to claim warranty. Have the back plate off. And inside, that bits fall out. We have a selection of plates. So you got that particular plate there wired up to that side. Can we separate them? And then you got the little gasket seal that was connected to the other polarity. So it's literally just a stack of plates that you run electricity through. How fascinating. And then at the back you've got like your water holes and orifices, or water comes through the bottom. It's electrically charged that goes through, and at the top falls down and gravity pushes it down to the scrub head. Not very exciting really, is it? Now while I was looking at the functions of what this circuit board does, I just brought up the manual here where it talks about the pin connections that go into this controller. So I'll start off at the bottom. So here we have your 12 volt rail, two circuit breakers. So you've got a 4 amp circuit breaker there. It then goes into the board. Then got another 4 amp circuit breaker here for the pump. For the ec-H2, it's got a pump at the bottom of the machine that pumps water up to the module. And then there's a capacitor across that pump. And coming out of here, we've got that other pump here, which is in the that little black box. So we've got that other pump there connected to the board. So obviously, take through there. Then we've got the ec-H2 module itself. So we've got two wires there each. Goes to the module. Back. Down here, what we got here? We got a ec-H2O flash switch. So that was a little push button switch on the front. Like so. And then here on the output, we have a pressure switch for 6 psi plus or minus 2 psi. So obviously that's reading what the pump is reading. Pump pressure in up to 6 psi. Switch opens. Pulling that down to ground. So obviously that knows when it's up to pressure. Got a couple of negative connections going out there to negative rail, and then you've got your CAN bus positive and negative. So that all looks rather straightforward. So we'll have something. Yeah, so I'll have power. So I have 24 volts going into the board. We'll have a voltage supply going to that pump. That pump's fed externally. Then pulled down to ground. So yeah, that looks fairly simple really. So where's that little pump we had earlier? So what's the voltage in this pump? This pump is DC 3 volts. So on this board, it's taking 24 volts in, dropping that down to 3 volts. So again, it's probably about right. Yeah, so if it's a microcontroller, you're probably going to want 3 or 5 volts. So they're probably going to have 3 volts for that, which is probably what this inductor and capacitor is. It's probably part of the power supply for the 3 volts. So yeah, these ec-H2O boards are actually fairly complicated. One of the things I do want to check quite quickly is how much voltage is left in this battery. Because I don't know if this machine had it on here. I think it's 2016, this machine. So obviously this battery's coming up to sort of 8-9 years old. I wonder how much power is left in it. But as for circuitry wise, it's reasonably complicated. But from the eye, I can't see anything blown or anything. So yeah. So that's what's inside an ec-H2O module. Just have a plastic thing with loads of plates in there which they fire electricity through. You've got your control board here, but this control board here does all the clever stuff. Power comes in, you've got your CAN bus, powers a couple of motors. So yeah, this is just a quick one for Christmas Day. I'll just stick a multimeter across that battery. We're getting 2.4 volts, which is quite a bit low. I'm guessing the battery like this is probably going to be 3 volts. So could that be the issue? The battery's gone flat and that's caused it to have an issue? I don't know. I don't actually have one of these machines here at the moment to actually plug it in and test it. But again, a lot of these machines, when they start getting to this sort of age, people don't want the ec-H2O in the second-hand market. A lot of these things go to like car garages and all sorts of places where they sort of abuse them, and this isn't really the right thing for them. But I'll keep this hanging around, and if I do come across another one, I'll have a play with it and see what I can find out. So that's just the end of my quick short one for Christmas. Thank you very much for watching, and goodbye.